Yeah, dear listeners, myself Hemanand, I'm working in MITS College, Assistant Professor, CSE Department. So here, I would like to give you an introduction about artificial neural networks and the need of neural networks. Right. So here, the content is simple. We we are going to discuss about the definition of neural networks and the key benefits what we are getting here, and what about the biological neuron and how it is working, and what is the relation between biological neuron and artificial neural networks. That means, here in a simple way, I can say that in order to work with artificial neural network, or in order to create an artificial neural network, we are trying to utilize the characteristics of biological neuron on a simple way, right? So I'll let you know how the characteristics of biological neuron or helped you to create or construct an artificial neural network, right? So here the scenario is, coming to the definition of artificial neural network, the, an artificial neural networks is a massively parallel distributed systems or distributed processors made up of simple processing units, right? Which will naturally process and store the information or the store the knowledge or store the result, right? And you can retrieve the result whenever you are required for that, right? It is as similar as the things like an experiment that you are going to conduct, right? You will have some input data, and you will process the data, and the produced result, after processing a result will be produced, and the produced result will be stored somewhere, and you can access the result whenever you want, right? So if you are storing something in your computer, so unless and until you remove that data from the computer, you can restore or you can collect the data. So this is what the basic logic behind working of artificial neural networks. So coming to this definition, you can see, observe that it is a massive means a huge amount of distributed processors. Generally, if you consider any specific computer, right, you will have a processor. But here, in making a artificial neural network, you definitely will have more amount of processors where the data will be distributed among all the processors to process, right? And this processor is nothing but a simple processing unit. This will process your data, right? So on a single line, the data will not be processed. That data will be distributed among things, right? And finally, you will produce some output. That output will be, we represent it as knowledge, right? And that knowledge will be stored, and whenever you require that, you can recollect it. What, right? This is what. And here, generally, this artificial neural networks definition resembles the brain in two respects, in two different perspectives. The first one is, knowledge is required by by the network from its environment through the learning process, right? Knowledge is acquired by the network. So you treat it as your brain, right? The network is nothing but the environment which is surrounded by you, and there are many things that are provided in the environment, and from that particular environment you are going to learn something. You are going to learn something that we generally referred as traditional learning. That is the way how you are learning from the experiences, right? From the environment and from your observations, everything, right? Your mind or your brain will know that you should not touch fire, right? You should not touch fire. So this is how your brain accepts this. When you touch some fire, it shows some effect on you. So with that effect, that shows some negative effect on you, so automatically you will learn that you should not go to that fire. This came from past experience. Once you have done it, you will result something. So from that result, you are able to understand whether we can do it or not. That is what an artificial neural network. Artificial neural network. That means artificially we are preparing something and that will think and act like human being. This is what scenario. And in the second thing, interneuron connection strength. Generally known, we will call it as synaptic weights. Interneuron. Suppose so we will think like this particular brain, whatever we have, that brain will have millions of neurons in our brain, neurons, and these neurons are interconnected to each other, right? All the neurons are connected to each other in different ways. They are able to form different types of networks. Okay, so in the similar way, here we are using the name it as multiple number of neurons in our brain are connected to each other, right? And we call that as synaptic weights. I will show you this the architecture of a brain and how it will work like this. All these things we will see, right? And here the next thing is, what are the benefits, right? What are the benefits that we are going to get when you are using artificial neural networks? And you just try to imagine everything that whatever we have discussed here. You just try to compare with the brain, right? So the first thing is nonlinearity. So generally, what do you mean by nonlinearity? Nonlinearity means try to understand the linear first, right? Whenever the input is increasing, automatically the output will be increased for any specific function. If you consider any specific function, okay, let we will try to consider a function called f of x. F of x is equal to 2x plus 3, right? The function is defined as f of x is equal to 2x plus 3, and where we are going to give the input for the value input for variable x. So whenever you are increasing the value of x, that means you can start from minus negative numbers also, or any integers or real numbers, right? So whether you can give minus 3 to that particular function and plus 3 to that particular function, plus 4 plus 5 plus 6, if you can give by the input by increasing it, automatically if you try to draw a graph between this input and output, it resembles a straight line which goes up, right? So this is what this is linearity. So whenever you are decreasing the input, automatically it will come down. It is also seems linearity only. Okay, but here the thing is, we are not behaving in that way. A human brain will not behave in that way. So it generally requires a non-linearity, right? So sometimes depending upon this particular scenario, our action will be performed. As an example, you can take the function like x square. F of x is equal to x square. If you give minus 3, it results as 9. If you give plus 3, it results as 9. If you draw anything, it will not come as a straight line. It will come as a curve, right? So along with the increase of input, the output will also increase. That statement will not work with non-linearity. Okay. So here, the ANNs are capable of modeling and capturing a non-linear relationships. So this non-linearity is a benefit that you can obtain from this particular artificial neural networks. And second one is adaptability. So your body nature and your brain will adaptable to the changes which are occurring in the environment, right? So that means here a scenario is will be like if some problem occurs, according to that problem, your brain will think about the solution. If a different kind of problem occurs, then your way of thinking in solving for that particular problem will also change. So sometimes we are going to solve a particular problem, and we gone through some up to some particular step, and in the meanwhile we thought that it is not a suggestible solution, right? In that particular scenario, we can come back and we can go with another option. Okay, so we are trying to find a best fitted solution for our problem in thinking a different number of ways. And similarly, we are just preparing an artificial neural network, which is an electronic device, right? And that should go with all the possible ways. That means that you think all the possible ways, and hence it has to go with the best possible way among all the solutions, right? This is called adaptability. In another way, your human body will be adaptable to very cold temperature like 27 degrees or 20 degrees also. And similarly, your body will be sustainable in 40 degrees temperature also. For both the different temperatures, your body will be sustained in a similar fashion. That means we, even though there are many number of changes in the environment, your body is capable of ad- adapting everything in the similar fashion. Whether whatever the problem it may occur, the system should be adaptable to the changes, right? So this particular thing will also come with back propagation, like previous or past experiences, right? And the third one, fault tolerance. Fault tolerance is one of the benefit that we will get. So what do you mean by this fault tolerance? Assume we have number of neurons, right? So if any neuron fails, right, so means some kind of problem occurred, right? Even though with the remaining number of neurons you are able to think and complete the process many times, right? In the similar fashion, if any one or two processors, these are just electronic device. Think once, this particular artificial neural network is nothing but it is a massive collection of processors, right? Many number of processors are there. Processor is an electronic device, and you should remember that any electronic device may fail, right? So here the scenario is, even though if one or two processors are failed, then with the remaining processors, the network should complete the task. Okay, the process should not stop. This is called fault tolerance. Fault. Some fault is occurred, some problem was came, but still it is managing with the remaining things, right? So that means ANNs can exhibit robustness to noise and partial failures. Sometimes failures will come due to their distributed nature. They can still perform reasonably well, even if the individual neurons or connections malfunctioning, right? And parallelism. So one more benefit is parallelism here. The ANNs are inherently parallel systems, parallelly distributed. I told you, right? In the definition itself, we have discussed that the ANN is parallelly distributed. So, and many that means that network will form in different layers. Each and every layer will have number of neurons, right? So this parallel processing has a capability that can lead to efficient computation of various things, right? So the next one is learning from data. So here, learning from data. Learning from data means based on the past experiences, right? Based on the past experiences, the system is going to learn many things, like discovering the patterns and features, right? That may not be apparent to the traditional methods. Suppose a letter is given to you. Suppose A is given to you. That particular letter can be written in many number of ways by many number of people. Everyone will not write A in the a simple style, same style, right? They can write a specific letter in an own style. Even if you operate a computer, right, you will have different font styles. In the similar way, human beings will also write. But here you are preparing a machine that should recognize the specific letter in whatever the format it is or whatever the style it is. Okay. So for that purpose, learning from the data. And the thing is generalization for next benefit. So generalization means it can generalize from the training data unseen examples, right? Previously we have not seen an thing I will tell you one more thing. Previously, right, you have seen me in this particular style, and after a few days you might see me with a bald head, right, and you might see me with a big bird, right, you might see me without mistakes. In different styles I can appear to you, but after that, after a few days I might come in a different style, but you should remember me or recognize me. This is what generalization. As you have seen me in different styles, even though if I came in a new style which you may not have seen me previously, right, even though you have to recognize me. That means it is an unseen data. That unseen data you should recognize properly, right? The prediction should be done correct. This is called generalization. So these are all different benefits that you will get by using artificial neural networks, right? Here the next one is applications of artificial neural networks, where we can use these artificial neural networks, right? We can use these artificial neural networks in different fields. Example in computer vision. So object classification, object detection, these are different tasks that can be performed in computer vision. For that we can use artificial neural networks. And natural language processing is in another field. So in natural language processing we can convert the text to speech and speech to text, right? I'm right now I'm discussing something, so whatever the discussions I made, that will be translated into text or machine translations from one language to another language. We can translate the data, right? These are all various tasks that can be performed under natural language processing, where we can use artificial neural networks. There is a chance where we can use artificial neural networks. And healthcare systems, even in healthcare systems, for recognizing a medical diagnosis, we can use artificial neural networks. And finance, for predicting stock market, that means for predicting the value of a stock, how it is varying based on the past experiences, right? How in the previous quarter or previous year, how the results came, and depends upon the results, how the stock was reacted, right? How it was changed, whether it moves up or moves down, right? And similarly, we can find fault detections, right? If anything uh, anomalies, right? Some unusual things happen, so where they will happen, that will also be found using artificial neural networks, right? Autonomous systems, autonomous vehicles will be there, right? Even in manufacturing systems and in entertainment in the sense, if you are using YouTube, then recommender systems will work there. If you continuously go with the same kind of series of videos, automatically the next time it will suggest you to see the similar kind of videos. It will suggest you. So that comes under recommender systems. So for that recommender systems also you can use artificial neural networks. And in robotics, in e-commerce, right? E-commerce websites are there like Amazon, Flipkart, Myntra. So different kinds of e-commerce websites are there. So there also will show you similar kind of products to purchase based on your previous. If you have already created an account and you have searched for few things continuously, and they will recommend you the similar kind of products, right? So for this also, they will use artificial neural networks, and agree in even in agriculture also they will use. That means for monitoring the crafts, right? We can use, and security for providing antiviruses. So mean to which applications we have to provide antivirus, or which for which applications we have to provide different kind of style things. For that also we can use artificial neural networks, and in a similar fashion you can use in education, logistics, and supply chain, right? So in this way we can use artificial neural networks in various kinds of applications, right? And the next one is biological neuron. So before understanding how we are going to prepare these artificial neural networks, right, the characteristics of artificial neural networks, we should be able to understand how a biological neuron, biological means a human body, right? Our brain contains many number of neurons, as we have discussed previously, and how a neuron will look like and how it will be processed, right? These things are very important for us. So when going with this biological neuron, if you observe this particularly this particular thing, right, the basic parts of a biological neuron are cell body, and nucleus, axon, and dendrites, right? These are basic parts that we are having in biological neuron. And what is the use of each and every part, and how that will be used to process the data, right? Remember, sometimes if I pose a question to you, right, you will give the answer immediately, even in your lecture classes or somewhere. If someone poses a question to you, you will give the answer immediately. And sometimes once you listen it to that question, right, you will recognize that yes, somehow or somewhere I have listened this question, but immediately the I was unable to give the answer. You're trying to get the answer, but it is not possible for you to immediately get the answer, but after some time you will get it. After some time you will get it, right? What happens during this duration? As we have discussed, right, we generally what we try to do is, whenever we listen about a few things regularly, right, that will be stored on in our neurons. And whatever you listen, it doesn't matter whether you are going to listen that regularly or very rarely, it doesn't matter. But whatever some data you are going to observe, right, that will be stored in your neuron. If it is a frequent data, then it will be stored in the upper layers of neuron, right, in your brain, upper layers of your brain. And sometimes the data which you go with very rarely, that will store in some deep layers of your neuron. Okay, if someone poses you immediately, then what will happen? If the question is a frequent one, then that will be stored in the upper layers. No, immediately the answer will come out. Otherwise, what will happen? If it is a rare question, then it will be stored somewhere, and the brain started connecting with all the neurons in your body. Right? The brain starts with connecting all the neurons in your body, and immediately it will if it is possible to connect with the existing neuron which in which the data is stored, right? If your brain succeed in connecting with with that neuron in which the data is stored, try to understand this, right? In all the amount of neurons, somehow every neuron is capable of storing some data, but for that particular question, data will be stored in some neuron, and from the to that neuron you have to make a interconnection, right? And in a simple way, The brain will have 10 power 11 millions of neurons. In human brain, I'll have 10 power 11 number of neurons, and all these neurons are connected in 10 power 15 number of ways, right? If you take 2 to 3 dots and you are able to connect 2 to 3 dots or 5 to 6 dots or 10 dots. If you are having 10 dots and I'm asking you to connect 10 dots, you can connect 10 dots in different ways. Now you try to observe, try to analyze. There are 10 power 11 number of neurons and they are connected in 10 power 15 number of ways. How big your network is in your brain, right? And how it will work hard to collect the information, right? So it is how we are trying to get it. So if the brain is able to connect the data or the neuron where the data is stored and it will try to extract the data, we can simply say that the neuron is fired out, right? The neuron is fired out. That is just a general term that will be used for us. And here, if you see this, we have a cell body. So inside that cell body, nucleus is there. So nucleus is a part where all the data will be processed, right? All the data will be processed. So once the data is processed, what you will do? The data is processed now, you will get some output, right? So that particular output will be sent through axon. Axon is there, right? So this particular part, what you have here, this is called synaptic weight. This is called synaptic weight or connection strength. We can also call it as connection strength. So here only the data will be stored. Output will be stored here in this particular part, right? And with the for all these axon, for all these axons, there are axon terminals. Sometimes we can call it as dendrites also. In a simple way, axons are used to transfer the data from one neuron to another neuron. Okay. Axons are used to transfer the data from one neuron to another neuron, and dendrites are used to collect the data from other neurons. Okay. So this is how a biological neuron will work. So based on this biological neuron, an artificial neuron will be made. Now we will look at the architecture of artificial neuron. Okay. So this is what the artificial neuron is, right? If you consider a biological neuron, this biological neuron is connected with a multiple number of ways. In a similar way, if you consider any artificial neuron, this is also connected. See here, this is what artificial neuron is. The entire thing. The entire thing is artificial neuron. Okay. So to process some data, that means we have to give the data to artificial neuron so that the particular artificial neuron can process the data, right? So the data will be treated as an input. So these are all the inputs. In different sources, inputs will come. Sir, how many sources would be there? That depends upon our application. That purely depends upon our application. So here, once think about the previous thing. Sir, I have data, right? We are just discussing about our human body. Okay. You are assigned a task and some amount of data is also given to complete the task. So can you able to complete the task? Think wise. In a different direction, you think. Like we have already finished many number of tasks. That means we are already tired. And now I have given you another task to complete. Are you capable of doing that task with the energy which you have performed previously? It is not possible, right? This time it is not possible because whatever the energy we have, I have consumed some amount of energy for in order to solve some particular tasks. And now my body came to some saturation point. and my body does not have that much amount of energy that I have previously had, right? So with the same intention or with the same energy, I cannot complete the task right now. So it means the main point here is energy. Energy is also a most important thing to complete a task, right? Similar fashion here, inputs are there. Think about it. Inputs are there, and for these inputs, we should have the artificial neuron should have some energy. That energy will be provided in the form of weights, synaptic weights. We call it as synaptic weights. Okay, that means the inputs are associated with the weights, and this entire things that are given treated like it is a sum of all the inputs and weights. Okay, so this particular sum, whatever it is there, will be given as will be come out as a output. Okay, this is nothing but summing part. We call it as summing part. Okay, so this is a function that was defined like this. Y is equal to, y is nothing but the output which is coming from the summing part. Okay, y is equal to f of, that means it is a function. I will tell you the use of this function also. F of w1 into x1 plus w2 into x2 up to wm into xn. So we have different number of inputs and different number of weights, right? Plus b, we can call it as a bias. B is a bias. I will tell you the purpose of bias also. Okay, and this particular summing part will be given as input to activation function, right? And this particular activation function, what is the use of activation function here? Come back to the definition of artificial neural networks. We are providing non-linearity, right? We are providing non-linearity. You think so? Weights are constant. Initially, we have assumed some weights. Initially, weights are there, right? They are constant. And similarly, some inputs are there. Input will be same, right? If you are processing the same things, if you are processing all the same things, what will happen? The entire thing becomes a linear process. You are not changing any input and you are not changing in weights. So entire thing becomes a linear process. But we need a non-linear application. So right, to provide this non-linearity, we are using activation function. Okay. To provide this non-linearity, we are using activation function. So once you have applied this activation function, see here, f of all this summing part. F of means is nothing but an activation function. Of course, we have different number of activation functions. Okay, we have different functions, number of activation functions. In based on our application, activation function will be defined, or that will be selected and will be used. And finally, it will produce an output. This is what the process is. This is how the artificial neuron will work simply. A single artificial neuron. Sir, what we have to do with the obtained output? What we have to do with the obtained output? See, here the case is we just thinking about there are many number of neurons in our artificial neural network. It is a network. A network contains many number of things. We have just discussed about the artificial neuron, architecture of an artificial neuron, one neuron, and how it will work. The output which will be provided here will be given as input to the next neuron. Okay, will be given as input to next neuron. This is how the scenario looks like, right? Yep. So in our coming lectures, we will see what are different artificial activation functions and how the entire neural networks will work and different applications, right? Thank you.